Question 20A, Part 1. A student uses a ruler to determine the volume of a cube A. The length of one side of the cube is 0.100 metre. Calculate the volume of cube A. Here's our cube, not particularly to scale, but it's worth noting that each side is 0.1 metre, or rather the width, depth and height are all 0.1 metre. Our question is asking us for the volume in metre cubed, and seeing as we've got all our measurements in metres already, we can just multiply them all together. So volume equals 0.1 times 0.1 times 0.1, because that's our width, depth and height. Pop that into a calculator. 1 times 10 to the minus 3 metre cubed, which is the same as 0.001 metre cubed. Question 20A, Part 2. Cube B has the same volume as cube A. The mass of cube B is 10 times greater than the mass of cube A. Compare the density of cube B with cube A. Use the equation for density to help your explanation. Well, first of all, if they're telling us to use the equation for density, we might as well put it down, see where it leads us. Density equals mass per unit volume. There we go. If cube B has the same volume as cube A, we can say that they both have 0.001 meters cubed worth of volume. Let's say that cube A has a mass of 1 kilogram. Why not? If mass B is equal to 10 times mass A, we've got our density of cube A equals 1 divided by 0.001, because that was the volume from before. 1000 kilogram per meter cubed. And density of cube B equals the mass of cube B, which is 10 times the mass of cube A, so 10 divided by same volume as before, 10,000 kilogram per meter cubed. So we've got our final answers: 1000 kilogram per meter cubed or 10,000 kilogram per meter cubed. The question is asking us to compare them, so let's summarize that in a concluding sentence. Therefore, density of cube B is 10 times density of cube A, something like that. Question 20B. A student researches how the density of air varies with the temperature of the air. Look at the graph for our findings. Describe the relationship between the temperature and density of air shown in the graph. Now, it might be tempting to look at this and say, oh yeah, it looks a bit like the 1 over x graph from maths, so it's inversely proportional. However, we don't know that for sure. So let's say exactly what we can see. Temperature is essentially our independent variable here, so let's talk about this first and how it affects our density. As our temperature increases, our density decreases. So let's definitely get that written down. As temperature increases, density decreases. Now the mark scheme says that this is sufficient for that 1 mark. If you wanted to give some more details, we can. It's not like it's some kind of straight line relationship. We've got a bit of a curve here. So let's add in at higher temperatures, density decreases at a decreasing rate. There we go. But that first sentence was enough to get that mark. Question 20C. Give one reason why a solid is more dense than gas. This is a particle model question. If we were to model a solid and a gas, this is our solid, this is our gas. Solid is more dense than the gas because, according to the particle model, in a solid, the particles are much closer together. As a result, there are more particles per unit volume. Question 20, Part D. A boat can be made out of concrete. Explain why a concrete boat floats, but a lump of concrete sinks. I feel it's best to draw a quick picture for this. So here's our concrete boat. It's a cross-section picture, and this is a block of concrete of the same volume. There's the same amount of concrete here as there is here. Here's our water. Of course, we've frozen time. If we were to allow the stop clock to run, this would immediately sink, whereas hopefully, especially the way I've drawn it, our boat will float. And the idea is there's a whole lot of air in here which contributes to our effective density of our boat. It's a bit like having a box this size which has the same amount of concrete as this solid lump, but there's a whole load of air inside. So if you were to look at the density of this hollow object as a whole, the density would be much less than this. Say a couple of things about this. Number one, the density of a concrete boat is much less than a block because the boat has air in it. See the picture below. Here we go. This means that the upthrust of the boat can be equal to its weight. allowing it to float here. Whereas the upthrust of the concrete block will be less than its weight, so it'll sink. It will accelerate downwards.